Right now, we're going to talk about the important points to check and pay attention to when inspecting the 2-pin injectors used in Volvo engines with 460 valves. First, we disassemble the injector. We're taking it apart. We remove the spacer plate. The most important point here is the valve closing point. There is an 8-degree grinding angle on the contact surface. At the same time, this spacer plate is the exact center point where the valve makes contact. Now, this area wears down along with the valve. Due to this wear, we have an old part under the microscope. We'll examine the socket area here in more detail at the top section. Here in the image, we can see the valve's closing point. The plate, the spacer plate. Due to the operation of the valve, this spacer plate experiences a certain amount of surface indentation. When low-quality diesel is used, vertical tears occur in these areas. This happens more often with faulty valves. So when a new valve is installed, if the surface of the spacer plate is damaged, it makes the new valve appear faulty as well. What needs to be done about this? The spacer plates need to be replaced with new original ones, and if they can't be replaced, then the pins of these valves should be removed and the surfaces should be lapped using 1200 grit diamond plate. We're now going to show the details of that. The seating part of the valve presses right at the edge of the hole on the spacer plate. Here, the sealing point is exactly the worn area we saw earlier under the microscope. Now, if the original part is available, it should be replaced with an identical original one. If not, and it can't be replaced, you can grip these pins with pliers and a vise and pull them out using the pliers. They are removed. These are serrated pins. After removing them, you need to use a diamond plate with 1200 grit on the surface here. Don't use coarser grits like 1000 or 800, because the surface needs to be polished very delicately. Valve leakage occurs. Using the 1200 grit diamond plate, apply very gently and press exactly at the center here. We held it in place. Again, using the figure 8 motion, we drew the figure 8 3 times. We rotated the surface 45 degrees. Pressed again and repeated the figure 8 motion 3 more times. It needs to be rotated another 45 degrees and continued in this manner. Otherwise, the parallelism values on the surface will be compromised. If lapping is done with too much pressure, slippage will again occur in the valve. Therefore, proper lapping without pressure must be done, and under a microscope, it should be confirmed that the lines here have disappeared. Only after that should the assembly process begin. Now here, we'll also check the valves in their seats. These are the valves we've manufactured ourselves. The most important point here is that, since these also have machines with automatic matching systems, there is a trigger stroke length between the valve surface and the angled ground surface with a tolerance of plus or minus 0.001 millimeter. Distance adjustment. These are automatic. None of it is left to human hands, absolutely not. The machine automatically measures the hole diameter and matches the pin to the hole diameter accordingly. At the same time, it also matches the trigger stroke length. All come out at a stable measurement. Another factor is that when the valve is closed, the sealing distance on the surface, between this surface and that surface, is around 10 millimeters. At that 0.10 millimeter is within a tolerance of plus or minus 0.005 millimeter. This is also related to the pull distance of the valve's magnetic coil. In other words, it determines the amount of fuel. The distances here are also automatically adjusted. The trigger lengths absolutely do not change. When assembling this, there's already a fuel adjustment shim that fits onto the pin at the top of the valve to make minor adjustments. There's also a spring inside. From here, You have the chance to fine-tune small amounts of fuel by changing the adjustment shim. Another factor, as we mentioned, is that the spacer plate of the valve must be very smooth, and there should be no tears on the surface during valve assembly. Let's examine this in detail under a microscope. We place it under the microscope and examine it in detail from above. Yes, this is the closing point of the valve we just looked at under the microscope. Here we see the male part the very tip of the pin. This is the area we refer to as the 8-degree section. Look how clean the face of the pin is spotless. In normally worn valves, tears occur on this surface. Let's zoom in on this. Let's take a closer look. As we zoom in, yes, we're adjusting the focus point. Since our angled valve is positioned at an angle, we don't get perfect clarity across the entire surface. We're going to look at these edge contours. If there are vertical tears along these edges when examined under a microscope, it means the valve is damaged and torn, and at the same time, there are also tears in the socket areas of the opposing platen we looked at earlier. In these cases, as we mentioned earlier, when you installed a valve, since the opposing spacer plate is also torn to the same extent, people often make a major mistake here. They say, "We installed a new valve." Even though we installed a new valve, the fuel amount doesn't increase. The reason is that the opposing spacer plate wasn't examined in detail under a microscope, and because there are tears on the opposite side where the pin presses, the valve can't fully close in its seat, which causes the diesel to flow back and prevents the fuel flow rates from reaching the desired values. These are the main factors. Yes, we just saw the valve under the microscope. We pay attention to the details in the seat area. Also, we pay attention to the surface of the spacer plate where the valve presses. While assembling, we make sure the area is clean. Now, we've placed the adjustment shim here. The spring is inside. The assembly, we do it like this. All right, that's it for this injector. That's all we have to explain.